Hi everyone. Today what we're going to go through is a very quick discussion, okay? This is a little bit of a quick hitter if you want to think of it that way. We're going to talk a little bit about creating our own equations. This is going to lead the pathway down to us taking a word problem, an application problem, and being able to translate it into algebra in order to be able to solve the problem. So today is a super important day, but I think it should be relatively straightforward. Okay, a couple things that we need to address, some key words, English translation into algebra, mathematical notation, but then also just a little bit on the difference between expressions versus equations. So let's get going. Take a look at the screen right now, and what you'll see is a bunch of key terms or phrases that you're going to see over and over again as we try to solve problems by using mathematical language. So a bunch of these we already know. Like that is, most of us, when we even read the word times in English, we think that multiplication symbol, and vice versa. When you see that multiplication symbol, we often will replace that with like 3 times 2. Divided, we are all good with our divided symbol, but we also know that we have our fraction line. Equals is quite often a term that we overlook when we read in English, just how explicit equals is. And you'll also notice that the is word in English is also another way for us to express equals. 5 is x. X is 5. Notice you would replace both of those with an equal symbol. We get to less than. Less than can be a little bit difficult. Sometimes we equate less than with an inequality symbol. For us, in terms of problem solving, that's a less likely route. Instead, where it becomes a little complex is less than is a comparison phrase. And so less than could mean that we're using subtraction. If we were taking a bigger thing and comparing it to a smaller thing. However, if we were going smaller to larger, then it could also mean addition. Both of those are kind of on equal balance. Okay, we see increased. Increased is also a comparison, but tends to lead more towards a positive. Decreased by tends to also deal with a subtraction. More than comes in on your less than, so we're often looking at something that it could be an addition, but possibly a subtraction. Square, I'm hoping I've converted most of you guys to being able to denote we would have a base, and all square means is an exponent of 2. We've also gotten much better at acknowledging product means multiply. And maybe if we bring back some old terminology, we also address sum means addition, plus most of us mean as addition. And then consecutive tends to add a little bit of a wrinkle. When you think about consecutive, the phrase that should pop into your mind is in a row. So if I say consecutive integers, then we would go like 1, 2, 3, 4, 5. Those would all be integers that we would count up in a row. Okay, those are all some key words or phrases that we're going to need as we start to jump in to be able to solve application questions. Okay, kind of our next area. What you see on the screen right now is an instruction that says translate each sentence into an expression. So what we're going to do is we're going to take all 4 of these expressions, these sentences, and we're going to change them into a mathematical expression. So the key thing for us, and if you can go up and just underline that word expression, that is super important to us. An expression is a phrase mathematically that has a value. It is not equal to anything. So as I go to create each one of these 4 statements, I will not have an equal symbol in each. It's important for us to denote that. Quite often we use the term equation to just represent any mathematical statement. We got to be careful. An expression is a statement of value. So let's take a look at A and see what we're talking about. A says 3 more than 5 times a number. What I'd like us to do on all four of these is try to pause it, get down what we think our instinct says to translate, and then we'll confirm. We'll do a little bit of a check. So let's tackle A right now. Pause it. Okay, we're back. So 3 more than 5 times a number. So if I allow that a number that's missing to equal x, then maybe we can see how we could translate that word. 3 more, 3 plus 5 times 5 multiplied by a number. I do want us to note, though, that 3 plus 5x would also have the same value as 5x plus 3. And so either of those statements would represent an expression that would be the translation of that English language statement. Okay, let's take a look at B. Pause it now. Okay, we're back. So now we have twice a number decreased by 4. Okay, let's try to translate it. Twice a number means 2 times a number, and I'm just going to pick a different variable here just for some variety, so I'll say like y. Now it says decreased by 4. So decrease it by 4. There we go. Also make a note that 4 minus 2y would not be an equal translation. I'm going to get rid of that cross out for a second so we can see. That would be a statement that would say 4 decreased by 2 times a number. That would give us a different statement. So let's take a look back up at A. Does it matter what order you add in? Nope. So we are good to write it either way. Take a look at B. Does it matter what order we subtract in? Yes, it does. So I could not accept that second statement. Okay, let's take a look at C. Pause it now. Okay, we're back. So that statement says 4 times a number increased by 8. And so we are also good then for everything we just stated that we could have written that. Okay, take a look at D. Pause it now. Okay, we're back. So now D says 2 times the sum of a number and 3. So 2 times the sum of a number and 3. I want you to notice that if I had written the statement 2 times the sum of a number and 3, notice that is not the same statement as the blue. We know that because we now know how to expand brackets, and so we can see that the blue statement would not give us the red, but also because we can translate that. Notice my statement says 2 times the sum of a number and 3. So if I'm to calculate the sum of a number and 3, I now need to do 2 times that. By only putting the 2 out in front of the B, I have not multiplied the whole thing by 2. Notice, in order to do that, I would need to have a plus 6 on the end. So hopefully we can see that that red would not be an acceptable translation. Okay, each one of those were us changing a sentence into an expression. Now we're going to take our last category. Now what you'll see on the page is the instruction to translate each sentence into an equation. So can I get you to underline the word equation? Because an equation is a statement of equality. It says that something is equal to something else. That means that I have to have an equal symbol in each one of these statements. Okay? Expression and equation are not frivolous terms. We don't throw them around. We make sure that we understand what each is stating. So now when I translate each of these 4, I have to make sure that I have the equal symbol in there. Okay, same thing, give A a read, give it a shot. Pause it now. Okay, we're back. So A says 9 less than 2 times a number is 28. Okay, so I get that the 9 less than 2 times a number, so I'm starting to see some of those key words. I see the 9 less, so I kind of think some subtraction. I see the 2 times, there's my multiply. I see the a number, so I can use a variable for that. How about I use m? And I see the word is, there's my equals. I want you to see how we could translate this sentence directly with one adjustment. Okay, the question says, 9 less than 2 times a number is 28. And I hope we see that we've translated individual words correctly, but not the meaning of the sentence correctly. And I want to come back to what we see underlined, 9 less than 2 times a number. Notice, 9 less than 2 times a number. So if we had to break that down into like values, then maybe what you do is you break that down into a value such as, okay, well, 2 times a number. Well, let me pick a decent sized number. How about I picked 14? Or sorry, 7. So that 2 times 7 gave me 14. That sentence would say 9 less than 2 times a number. So what is 9 less than 14? And we do a little bit of math and we go 5. So I want you to take a look back now at what 9 less than 2x means and see, would we get to 5? Hopefully we can see pretty quickly that we have that statement backwards. So I have to be very careful on my less than because I know the order that I subtract in matters. So to make that adjustment, I'm going to erase what I've got here. And I notice that I should have taken 2 times a number less 9. And what you would then see in that blue statement matches that English statement. Okay, subtraction matters the orders. We have to be very careful that we are subtracting correctly. Okay, I want everybody to pause it and give B a shot. Go ahead. Okay, we're back. So for a lot of us, probably B was pretty direct. The square of a number, I don't know, I'll use n for number. Square of a number, is means equals 25, and we are good. Okay, let's give C a shot. Pause it now. Okay, we're back. So I have no problem with us translating this sentence into this. Well, it says the sum of 2 consecutive numbers. Well, now, there's 2 numbers that I don't know. And so maybe I said A was the first number, and if I add B to the second number, is 7. So the sum of 2 consecutive numbers is 7. And I choose 2 variables. I need you to know that that is a correct statement. However, it completely ignores any of the relationship meant by the word consecutive. That I can actually write a more direct equation because I know something about consecutive values. So I want you to imagine then that I said that x was one of the numbers. Like specifically, x was the smaller number. Well, if x is the smaller number that's missing, we should be good that the consecutive number to x would have to be 1 bigger. And therefore, my other number would be x plus 1. There's my 2 consecutive numbers. Now, the question says the sum of it, so I'm going to add those together. We should be good that whether you put brackets around x plus 1 or not, doesn't matter, equals 7. You can see in that statement, x is one of the numbers, and x plus 1 is the other. It's x plus 1 because it's 1 bigger. I'm hoping, though, that we could also see we could have built a different equation. That we also could have built an equation based on the assumption that maybe y was the bigger number. Well, if y is the bigger of two consecutive numbers, then the other number must have been one smaller. Therefore, y minus 1 would have to be the other number. Now I can find the sum of that, and again, whether we have brackets there or not, doesn't matter. Notice that you actually have two good statements that you could write. I would want to see either of the blues. Either of the blues. The red is not specific enough. Okay, let's take a last shot on the last problem. Go ahead and translate D. Pause it now. Okay, we're back. So we also see that key word again, consecutive, and so now we know that that means a variable, and then the other number is +1 or -1, depending on what we view. I'm going to do the most common one, the most common equation, because I think for most people, they would tend to think of their variable as the smaller of two things. That way, the other variable is one bigger, as most people would prefer to add as opposed to subtract. Okay, this question says the sum of those squares, so I need to add in that sum operation. It then says the sum of the squares. That means that I have to square both of those values. So what you'll read in gold is the sum, and then you see your exponent 2 on both of those missing numbers for our squares. You see in blue the consecutive. Is means equals 74. And there we go. I'm just going to add in very quickly what that other one could have been had we viewed y as the larger of two numbers. The square of one added to the square of the other gives me 74. And there we go with translating. Okay, I'm hoping that this was a pretty quick video for us to be able to go through, but this is going to lay the groundwork for where we go next. Okay, look back over this video as you need to work on that translating. I think it's going to help us a lot. Okay, you've got a quick worksheet to jump in and play around with. Good luck.